Good day students, I am Somasundaram from Bharathidhasanar Matric Higher Secondary School, Arakkonam. So this is about quantum mechanical concept of atoms. This is the part 6 video. In this video we are going to see about quantum mechanical model of atom and Schrödinger wave equation. So according to Schrödinger, finding an electron in an orbit or in an atom is difficult. So we are considering an electron as a single point charge. By solving the equation, that is wave equation, we can identify the position of electron in an atom. So he proposed an equation that is called as Schrödinger wave equation. So that is nothing but H cap psi that is equal to E psi. E is energy here, psi is wave function. Wave function means it refers the wave nature of electron. Next, H cap, that is Hamiltonian operator. So Hamiltonian operator, it is actually a mathematical operator. With that, we can identify the position of an electron in a three-dimensional space, okay, for a moving electron. The Hamiltonian operator, H cap, that is equal to minus H square divided by 8 pi square m into dou square divided by dou s square plus dou square divided by dou y square plus dou square divided by dou z square and plus V. V is potential energy here. Okay. So using this operator, we can identify what is the allowed position of a particular object. Allowed position. So in atoms, what is the allowed position for an electron? Nothing but orbits or orbitals. So in quantum mechanical concept, we are going to go one step forward. In Bohr concept, we have derived about orbit. Now, one step closer to the atomic structure, that is nothing but orbital. So orbital is where the electrons are residing exactly. So using this operator, you can identify the position of electron in three-dimensional space. What are the allowed position? So now, see H cap, this is the operator. Now substitute the operator in the equation. What happens? You will get the value. Instead of H cap, we are going to substitute here. So what happens? You will put when you put this equation here, the psi will be multiplied with this equation. What happens? That H cap, instead of H cap, we are going to substitute this equation. What happens? Minus H square divided by 8 pi square m. Now, the psi is going to multiply within the bracket here. So, what happens? Dou square psi divided by dou x square plus dou square psi divided by dou y square plus dou square z psi divided by dou z square plus v psi. So this is the equation that is equal to E psi. Now we got this equation. Now bring E psi with the right hand side. What happens? The equation will become like this, minus H square divided by 8 pi square m psi with dou square psi divided by dou x square plus dou square psi divided by dou y square plus dou square divided by dou z square plus v psi minus E psi, that is equal to 0. Okay. When you solve this equation by substituting the energy value, you will get the 0. If you substitute the wrong energy value, you won't get the value 0. That means we can identify the allowed energy level using this equation. So that is why it is called as time independent Schrödinger wave equation. Here we are not mentioning any time here. Okay, without a time we are telling where the electrons can reside. That is known as orbital. Okay, so using this wave equation, we can identify or we can solve the energy allowed for a particular electron which can reside in a particular orbital. What are the features of quantum mechanical model of atom? See students, here also the quantization of energy has been accepted. The quantization of energy has been accepted because electrons can reside only the allowed energy levels, that is orbitals. It won't stay anywhere else where they want. Okay, so it is allowed in one particular orbitals only. That is known as energy quantization. Next, the existence of quantized electronic energy levels. That means ground state, first excited state, second excited state, third excited state. These are all the states are possible for every atoms. Next, Eisenberg uncertainty. According to Eisenberg uncertainty, it is difficult to accurately calculate the position as well as the momentum simultaneously. So that here they are adding another concept that is called as orbital. So they are introducing the new term called orbital, that is the position, the place where the electrons are residing. Next, we can identify the probability of finding the electron in an allowed orbital using the wave equation. Next, the solution of Schrödinger wave equation, which gives us the idea about allowed transitions, allowed energies, allowed orbitals. Next, the wave function psi itself has no meaning. Yeah, it doesn't give you any idea about that. But the psi square, it will give you the population density of an electron. So using that population density, you can identify the area or the volume occupied or the volume where the electrons are revolving around the nucleus. So that is called as orbital. That's all. So that is nothing but the modulation of psi, the function of xyz modulation square. Why we are using xyz? Because in three-dimensional space, we are using three axes x, y, z to find out a particle in a three-dimensional space. That is why the population density of an electron is psi modulus square. See here, there is a nucleus. Electrons are revolving around the nucleus in a particular position only. So we can identify the particle in that particular position using the axis x, y, z. That's all. So these are all the features of quantum mechanical concept. So thank you students. In this video, we have discussed about quantum mechanical concept of atom and Schrödinger wave equation. When you solve the Schrödinger wave equation, you can identify the allowed energy levels. Thank you very much students.